Okay, so the warm-up today is make this table. This is you don't need two of them. That's just my copy. So write that table down. It's counting by pi over 4s. So I'm not including the over 3s and the over 6s because what we do today, that's overkill. I mean, you still need to know them, but you don't need them today. So this is just a review. This is all, all of these questions will probably ask on the test that you're about to get back. So copy that table down, fill in the answers, and I guess I'll do the first two with you just to.
Simplify pi?
Pi won't be in your answer, so you don't have to worry about simplifying pi, I guess is the. So what's the sign of 0?
Absolutely.
You better not have downloaded that information because you took the test. You're like, I don't need that anymore.
The sign of 0 is 0.
0. And what's the cosine of 0?
1.
And the tangent, remember the tangent is y over x.
So it's 0.
Mr. Wolf, is there something underneath 7 pi over 4?
There is 2 pi. We go all the way to 2 pi. Pi over 4, if you need a quick sketch, there it is. What's the sign of pi over 4? Root 2 over 2. I don't want you to write root 2 over 2 today because we're going to be graphing and who knows what root 2 over 2 is, except that I'm telling you that root 2 over 2 is 0.7. And it's approximately 0.7. It's got a lot of decimals after it, but for graphing, 0.7 is plenty good. What's the cosine of pi over 4? And the tangent of pi over 4?
1.
All right, I'm going to pass back the test while you finish the table. We're going to use that as we build our graphs. Okay? So, at what point does sine start over? Like, when we go around the unit circle, how far do we go around before we just start over?
2 pi.
I would say 2 pi. So our entire graph is going to fit between 0 and 2 pi. Now I'm putting 2 pi there because I want to extend it out and show that it repeats. So let's put 2 pi about right there. There's pi. Pi over 2. 3 pi over 2. And I think that's enough for labeling. If we put pi over 4 on there, it gets a little bit messy. Obviously, if we put pi over 3 and pi over 6 over there, all of that would be really messy. So just put every multiple of pi over 2. And we'll kind of fill in. Well, we'll start with this and see. All right, so we look at we already have a table built. So basically, we did a table of values already that will help us make this graph. So the sign of 0 is 0. What's the biggest, I'm thinking about my y-axis label here. What's the biggest value sine takes? Or sine gets to? Look at your table. 1. And what's the smallest it gets to? Negative. Oh, it should get to negative 1. So right now all we're doing is taking our table of values that we made and putting them on the graph. And we're not really skipping over pi over 4. It's there. It's just 0.7 is not. I just don't want a hash mark for it just because it muddies up the graph. So pi over 2, we're up at 1. 0.7. Sine of pi is 0. Negative 0.7. 3 pi over 2 is negative 1. And if we play connect the dots, it's a nice smooth wave. It's not a jagged sawtooth thing. It looks like that. Now that's that's the only points we plotted. But what happens, think about the unit circle, what happens after 2 pi? Like after we rotate 2 pi,
You go again. You do it again.
you do it again. So what we're going to do is take the sort of a mental picture of that and just transfer it over, or copy paste, exactly. And so where will it end if we do copy paste? It'll end at 4 pi. And then 3 pi, and I'm going to label even less of this one. But I'm going to follow the same pattern. 0, 1s, and negative 1s are the only key points we need. Now, the danger is if you only graph the 0s, 1s, and negative 1s, you might be tempted to think a sine graph looks like that. But it doesn't look like that because there's more pieces to it. What would happen if we go backwards? Like thinking about the unit circle.
I'm just going to do the same exact thing.
It's going to do the same thing. So again, I'm going to sort of mentally copy 0 to 2 pi and back it up over here to negative 2 pi. But really, I'm just following the pattern now.
So essentially, you're just lining it up with every half step of pi. There should be a point.
The points I want you to plot the points at every pi over 2. Now we did pi over 4 to sort of emphasize that it's curved, it's not a jagged line. But when you're graphing these, as long as you have points at every pi over 2,
Yeah, which essentially. Yeah.
you're good. Well, and you make the graph curvy, not jagged. Right. Not entirely necessary, but I'm going to highlight what we call one cycle. That's the 0 to 2 pi. After that, it's just copy paste. So we could graph this forever. I mean, it would take a while, obviously, to go it forever, but we know how. You just keep copying
You wouldn't stop it.
that 0 to 2 pi. You just copy, paste, or copy and then paste, all the way out as far as you want to go.
We go backwards.
And we could copy, paste backwards as far as we wanted to go.
So those were those squiggly lines on that sheet on the answers.
What's that?
On the answer, do you have sign and 0?
We're going to have lots of squiggly lines.
Squiggly lines.
All right, let's answer some questions about the properties here. And I don't think you memorize these properties. I think once you understand the graphs, you could answer any of these questions pretty easily. What's the domain? Domain is x's.
So negative infinity.
Negative infinity to infinity. It goes forever.
And is it always?
Now, you have to be careful with that because sometimes you think, well, the domain is 0 to 2 pi. Like, no, the first cycle is 0 to 2 pi, but the graph goes forever in both directions.
Is this one always going to be?
How about the range?
Negative 1, 1.
Negative 1 to 1 with brackets because we do get to negative 1 and get to the graph equals negative 1 and 1 at places. Period. This might be a new term because we haven't used this in.
Decimal point.
It's not like the period at the end of a sentence. That's not the kind of period it is. Periodic, maybe you've heard that term, means something repeats. In fact,
0 to 2.
if we skip the first blank, you can probably get it by answering the second blank. This means that the graph repeats every 2 pi units. So we say the period is equal to 2 pi. After 2 pi, it starts over. Which kind of makes sense because it's kind of based off the unit circle, and every 2 pi we start over. The amplitude of y equals sine of x And again, if you read the second sentence, you can probably figure out what the amplitude is. This means that from the middle value of the graph, so the middle value of the graph, right in the middle, the wave goes up and down. How far up does it go and how far down does it go?
It goes 1 and down 1.
So its amplitude is 1 because it goes up 1 from the middle
Maybe plus or minus 1.
and down 1 from the middle. That's a good question. Is it plus or minus 1? Amplitude sort of implies plus or minus, so we're just going to say the amplitude is 1. And sort of built into that means it goes up and it goes down 1. That's a good question. The amplitude is positive, but it does go up and down 1. Okay, that's a super important graph you need to know. Now, do you memorize the graph? Do you build it from the table I wouldn't build it from the table every time. I would hold off on deciding how you want to memorize it because it's going to look a lot like cosine, and you're going to get the hang of these, and it's going to go okay, I think. But you are going to have to know what that graph looks like.
Probably write the thing like on the board somewhere just for like a day or two.
What's that?
The chart thing.
This picture or
Yeah.
this picture or both? Because they
Just the,
like.
I disagree.
I guess the idea is we want you to make the connection between the unit circle,
yeah.
the table of values, and this picture of a
Just
graph.
one simple example.
Like they all go together. And the better you understand one, the better you understand the others.
Easier.
Right, it makes it easier to memorize, although I'm not even really comfortable with that. It's easier to understand the others. All right, y equals cosine of x.
So we're just gonna put X in.
X and y.
So
There's some similarities and differences here. Repeats after 2 pi.
wait, it's not going like
Pi over 2, 3 pi over 2. Again, I've still got my table that I'm looking at. Except I'm looking at the cosine column, not the sine column. Thinking about how to label the y-axis, how far up does cosine x go? What's the largest value of cosine? 1. And what's the smallest value of cosine? -1. It's not the same. Well, some of the stuff is the same. So be careful when you say it's the same as sine. A lot of the stuff is the same, but not all of the stuff. So we look at our table. What's the cosine of 0? 1.
so it's translated up one thing.
What's the cosine of pi over 2? I'm not even going to do the pi over 4s. 0. What's the cosine of pi?
It's just the opposite way. It's just flipped.
Now, again, if all you do is those 5 points, you're tempted to do a V. You know that's not right. I hope you know that's not right. But there's the first cycle of the cosine wave.
So it's just flipped.
It's not flipped.
Oh, it's
You're trying to figure out how they're related, and I like that you're trying to figure it out. It will be more helpful if we'll continue to sketch that out to 4 pi, right? Because after 2 pi, things repeat on the unit circle. So let's do the copy paste thing. Again, it's just patterning between -1, 0, 1, 0, and so on. But once you get the first one down,
just the opposite.
and again, I can extend it back 2 pi and do the same thing. And again, I'm going to highlight the 0 to 2 pi because that's the part you need to know. Once you know the 0 to 2 pi part, you just copy paste however far in each direction you want to go. Okay, some of you are saying it, so let's go ahead and look at it now before we even do the properties. How would you say that the sine graph and the cosine graph, like how are they related to each other?
They're just flipped.
Is it the same?
But they're not flipped.
One.
If I flipped sine, I don't get cosine.
They start translated in
They're
some direction.
they're scooted over, and a better math way to say that is they're translated. They're left-right translations of each other, right? If I scoot the sine graph over pi over 2, then it would look like the cosine graph.
Because sine rows, cosines there's 1. So you
The big deal is, where do I start? If you know where to start, you can figure out the rest. So sine of 0 is 0, cosine of 0 is 1. After that, you just follow the pattern. But the starting point is super important. In fact, I'm going to write that on here. Sine of 0 is 0, because that's where we start. So we'll start at 0, 0 for sine. For cosine, the cosine of 0 is 1, so you start your graph at 0, 1.
Could you move up the table?
After that, they both look the same, right? If you took the XY axis off, the pictures would look the same. They have the same shape. One is just scooted over from the other. So a big thing is knowing where they start, because if you know where they start, you can just follow the pattern after that. All right, let's answer some questions about cosine of x. The domain is negative infinity to infinity. The range is negative 1 to 1. So domain and range have to do with the shape of the graph. Because the shape of the graph is the same for sine and cosine, they have the same domain and range. Not the same graph, but some of the properties are the same. How about the period of cosine? When does it start repeating? At 2 pi. Every 2 pi it repeats. Its period is 2 pi. So they have the same domain, the same range, the same period. How about the amplitude?
It's going to be the same.
It's also 1.
The only thing that's different is the starting.
So one way to say it is the only thing different is their starting point. Which is why I try to make a big deal out of cosine starts at 0, 1, sine starts at 0, 0. After that, I don't want to say they're the same, but it's kind of the same. So there's 2 graphs you have to know, but is it really 2 graphs or is it one graph that shifts a little bit? Yeah, one's special. I don't know which one's special if they're... All right, tangent of x.
It's going to be both in the same.
This is going to be a little bit weird now.
It's just going to be both and then layered again.
Well, I think our best bet is to go with our table.
This is where the table and the board will be.
Now, tangent's different, so I'm going to warn you. Tangent's period is pi, so we can space our graph out a little bit more and go 0 to pi to get the full graph in. And then negative pi, and then out to 2 pi if we want to see several pictures of it. Let's see. Tangent is sine over cosine, which is y over x. We have our table.
0 over.
So y equals tangent of x is undefined when cosine is 0. Now that matches our table, right? When cosine was 0, tangent's undefined. This means y equals tangent of x will have asymptotes. If the denominator is 0, that makes an asymptote. So we have asymptotes at pi over 2. And at 3 pi over 2. And you might guess where the other asymptote is on the left. Yeah, negative pi over 2. cheat sheet, the little table we made, the tangent of 0 is 0. The tangent of pi over 4 is 1. This is going to look really weird until we know what we're doing here. Tangent of 3 pi over 4 is negative 1. Tangent of pi is 0. Pi over 4, we're up at 1. 7 pi over 4, we're at negative 1. Okay, 2 pi over 0. If we go... Well, you tell me. What do you think? What's the tangent of negative pi over 4? Either think about the unit circle, or think about the picture that we have drawn so far. What do you...
It was nudged to the left the first time, so it's probably going to be nudged to the right. Oh, wait, no. Just gonna be,
Just look at the pattern going on here. It's going to be negative 1.
yeah.
Now, how we connect the dots on these, see, these are asymptotes, so we'll use them as asymptotes. Looks a little bit like x cubed. Graph of tangent is significantly trickier than sine and cosine. Mainly because there's a denominator and that introduces asymptotes, and now you've got all sorts of crazy things going on.
It's just repeated.
It does repeat, so yeah, I mean, you still only need to know the one cycle of it, and then you can just do your copy-paste thing. That's true. Y equals tangent x has asymptotes at all of the... How would you phrase what goes in that blank? What are the x values of the asymptotes? So negative pi over 2, pi over 2, 3 pi over 2. Be careful. It's not really anything over 2. Because it's not 2 pi over 2. Right? 2 pi over 2. It's 1 over 2 and 3 over 2. So it's at all the odd pi over 2's. Since cosine of x is equal to 0 at all of the odd pi over 2's. The domain
Do I have to use that U thing?
is... Okay, so you could use the u thing, but you'd have to do that forever, right? Negative pi over 2 to pi over 2. Pi over 2 to 3 pi over 2. Instead, let's just say where it's not, where it doesn't work. What can't x be? Well, it's kind of the same thing as the asymptotes. Like these two questions go together at the odd pi over 2's. So k pi over 2, where k is an odd integer. Ranged, it is infinite. Let's write it as an interval though. So how far down does it go? And yep, so negative infinity to infinity. Olivia?
What does the one above that say?
X can't be k pi over 2. X can't be an odd pi over 2. How about the period? How much of the graph do you need to see the whole graph? That's one way to phrase the period. How often does it repeat?
Every 5.
Good. It repeats every pi unit. That's a key difference there between sine and cosine. I mean, the graph obviously looks different, but among properties, that's a key difference. It repeats every pi rather than 2 pi. And then it doesn't really have amplitude. Amplitude goes with wave, so amplitude doesn't really make sense for tangent. Sine, cosine, and tangent are by far the most important of the graphs. So we're going to quickly go through the other three because they're not nearly as important. Cotangent, cosine over sine. So that means it has asymptotes where sine is 0. So again, it's sort of like it's been shifted, except that instead of increasing, it's a decreasing. So there's what cotangent looks like. Again, not nearly as important as tangent. And you can fill out the properties later. Secant. Told you we were going to go super fast on this. Maybe the most important part of the secant one is this box down here. To graph y equals secant of x, first graph y equals cosine of x, and then draw asymptotes and u's. And I don't know what that means yet, but let's first graph cosine of x. Ooh, do we remember where does cosine of x start? We know what the shape looks like. When x is 0, what's the cosine of 0? 1. So it starts at 1, which means it ends at 1. This is how you start to graph these fast. I know where it starts, which means I know where it ends. And then I can fill in the middle because I know what the wave looks like. It says graph it with a dotted curve. Sorry if you're using a pen and you didn't do that yet. You'll be okay though. So there's cosine. We've seen that. When cosine is 0, there's an asymptote. So wherever cosine is 0, you can put an asymptote. And then this is a little bit weird maybe, but 1 over makes there be u's off the peaks and valleys. You don't like that one. Fair enough. Alright, today's homework is really just more like practice drawing basic graphs. Later in the week we'll move things around, do the parent function transformation stuff, but that's not for today. Today is, let's make sure we understand what the graphs look like.
Yeah.
Then we'll move them around. So, I would say finish this, see if you can do number 6, and then worksheet 1. And we'll go over them tomorrow.
I don't remember its normal schedule.
So worksheet 1 is just the first page. It's just doing the graphs again, and then answering questions about properties and some matching. So the homework should take less time than the notes did, really. In theory. Famous last words.
I mean,